When facing challenges with stress cone installation for medium voltage cable terminations, several options can be considered. Firstly, explore using a different transformer. A transformer with a smaller footprint might provide the necessary space to accommodate the stress cones inside the enclosure. Secondly, consider installing the stress cones outside the transformer. If internal space is truly limited, mounting them externally is a possibility, but ensure they are properly protected from environmental factors and easily accessible for future maintenance. Thirdly, using a pre-terminated cable offers a solution by purchasing cables with stress cones already installed. This eliminates the need for on-site installation and reduces space requirements. Fourthly, installing a stress cone cover might reduce the overall size needed if space is tight. Fifthly, consider using a non-fill termination. These terminations do not require stress cones but must be used per the manufacturer's instructions, as they may not be suitable for all applications. Safety is paramount. Ensure any modifications or alternative solutions strictly comply with all applicable safety regulations and manufacturer specifications. Verify that the proposed solution maintains the electrical performance and reliability of the system. Accessibility for future maintenance and inspection should be a key consideration when selecting the solution. Factor in the costs of any modifications and their potential impact on the overall project budget. Consulting with the transformer manufacturer, the cable supplier, and a qualified electrician or engineer is highly recommended to explore the most suitable option based on the specific requirements and constraints of the installation. Remember to carefully review NEC Article 300.40 regarding medium voltage cable installations. The selection of cable and termination methods must be appropriate for the voltage, current, and environmental conditions. The NEC provides guidelines for cable bending radii, support, and securing methods to prevent damage and ensure safe operation. When using stress cones, it is crucial to follow the manufacturer's instructions for proper installation and grounding. Stress cones are designed to reduce electrical stress at the termination point, preventing installation breakdown and potential failures. If external installation of stress cones is considered, ensure that the enclosure provides adequate protection from moisture, dirt, and physical damage. The enclosure should also be properly grounded to minimize the risk of electrical shock. Consider using shielded cable and grounding the shield to further reduce electrical noise and improve system performance. Regularly inspect cable terminations for signs of damage, corrosion, or overheating. Thermographic scanning can be a valuable tool for identifying potential problems before they lead to failures. Maintain accurate records of cable installations, terminations, and maintenance activities for future reference. Consider using cable management systems to organize and support cables, preventing strain and damage. When working with medium voltage systems, always use appropriate personal protective equipment, including insulated gloves, sleeves, and eye protection. Follow lockout-tagout procedures to de-energize equipment before performing any maintenance or repairs. Be aware of the potential hazards associated with medium voltage systems, including arc flash and electrical shock. Implement safety measures to mitigate these risks. Properly train personnel on the safe handling and maintenance of medium voltage equipment. Keep up to date with the latest industry standards and best practices for medium voltage cable terminations. Consider the long-term reliability and maintenance requirements of the chosen solution. Select materials and components that are designed to withstand the operating environment and provide a long service life. Regularly inspect and test cable terminations to ensure they are functioning properly. Address any issues promptly to prevent failures and downtime. Document all maintenance and testing activities for future reference. Consider the impact of the chosen solution on the overall system efficiency. Select components that minimize energy losses and improve system performance. Use energy-efficient transformers and cables to reduce energy consumption. Implement power factor correction to improve system efficiency and reduce energy costs. Regularly monitor system performance to identify areas for improvement. Continuously evaluate and update maintenance practices to ensure they are effective and efficient. Consider the environmental impact of the chosen solution. Select materials and components that are environmentally friendly and sustainable. Implement recycling programs for used cables and components. Minimize waste and pollution during installation and maintenance activities. Promote environmental awareness among personnel. Consider the security of the medium voltage system. Implement measures to prevent unauthorized access to equipment and cables. Use tamper-resistant enclosures and hardware. Install security cameras and alarms to deter vandalism and theft. Regularly inspect and test security systems to ensure they are functioning properly. Coordinate with local law enforcement and security agencies to address any security concerns. Consider the impact of the chosen solution on the surrounding community. Minimize noise and visual pollution. Communicate with neighbors about planned activities and potential disruptions. Address any concerns promptly and professionally. Be a responsible and considerate member of the community. Consider the long-term growth and expansion plans of the facility. Select solutions that are scalable and adaptable to future needs. Design systems with sufficient capacity to accommodate future loads. Plan for future upgrades and replacements. Regularly review and update system designs to ensure they meet changing needs. The decision should be based on a thorough evaluation of all relevant factors, ensuring a safe, reliable, and cost-effective solution. When selecting a termination method, consider the conductor material, insulation type, and cable size. Ensure that the termination is compatible with these factors. Use the correct tools and techniques for preparing the cable and installing the termination. Follow the manufacturer's instructions carefully. Properly clean and lubricate the cable and termination components. Make sure that the termination is securely fastened to the equipment. Test the termination after installation to verify its integrity. Use a high potential test to check for insulation breakdown. Use a low resistance ohmmeter to check for proper grounding. Monitor the termination regularly for signs of overheating or corrosion. Take corrective action promptly if any problems are detected. Keep a record of all inspections, tests, and maintenance activities. Use the data to identify trends and predict potential failures. Implement a preventative maintenance program to minimize downtime and extend the life of the system. Continuously improve the design, installation, and maintenance practices to enhance safety, reliability, and efficiency. Consult with industry experts and attend training courses to stay up to date on the latest technologies and best practices. Share knowledge and experience with colleagues to promote a culture of safety and continuous improvement. These factors can further influence the decisions. In addition to the NEC requirements, IEE standards provide guidance on cable testing, grounding, and maintenance. Following these standards can help ensure the safe and reliable operation of the medium voltage system. Proper coordination between the electrical design, installation, and maintenance teams is essential for success. Open communication and collaboration can help identify and resolve potential problems early on. A well-defined scope of work, clear roles and responsibilities, and regular progress meetings can help keep the project on track and within budget. Document all decisions and changes to the design and installation to maintain accurate records for future reference. A comprehensive commissioning process is essential for verifying that the system is installed and functioning correctly. Conduct thorough testing and inspection to identify and correct any deficiencies. Provide training to operating personnel on the proper operation and maintenance of the system. Document all commissioning activities and results. A robust preventative maintenance program is essential for maintaining the long-term reliability of the medium voltage system. Regularly inspect and test cables, terminations, and equipment. Lubricate moving parts and clean electrical contacts. Tighten loose connections and replace worn components. Keep accurate records of all maintenance activities. A proactive approach to maintenance can help prevent failures and extend the life of the system. Continuous monitoring of system performance can help identify potential problems before they lead to failures. Use sensors and data analytics to track key parameters such as voltage, current, temperature, and vibration. Establish alarm thresholds and trigger corrective actions when deviations occur. Implement a remote monitoring system to enable real-time visibility into system performance. A data-driven approach to maintenance can help optimize system performance and reduce downtime. In summary, addressing space constraints with medium voltage terminations requires careful consideration of multiple options. By prioritizing safety, performance, accessibility, and cost-effectiveness, and by consulting with experts, you can achieve a reliable and efficient medium voltage system.